Today we're going to be talking about some nuclear chemistry and how to do nuclear equations. Now, I've got listed at the top some of the particles and radiation that we might come across. Remember that the helium nucleus, it's got the 4 on the top and the 2 on the bottom. Those are actually our alpha particles. An electron with a 0 on the top and a -1 on the bottom are our betas. Remember, the lower number for nuclear chemistry doesn't just represent the atomic number, it also represents the charge. So because the electron is -1 charge, we have the -1 here. Now we have positrons, which are just like the electrons. So we give it a little E there, but they've got a positive charge instead of the negative charge. Then we have neutrons, which have a 1 on the mass, but a 0 on the charge. Protons, which are basically the hydrogen nucleus, because it's got 1 on the mass and 1 on the charge. And then gamma radiation, which has no mass and no charge. So we might be asked certain questions to determine what is given off, or what type of things we start off with for these nuclear chemistry problems. And the thing that we want to make sure we have with all of these is that the top numbers on one side of the arrow equal the top numbers on the other side of the arrow. The bottom numbers on one side of the arrow equal the bottom numbers on the other side of the arrow. So let's go ahead and give this a try. Okay, we want to know what this thing is over here, and we are given what the products are. So we've got 0 plus 74 have to equal whatever that thing is over there. Well, we can just do the math, and we see that the top number over here has to be 74. We can do the same thing with the bottom number. -1 plus a 32 has to equal whatever our unknown is over here. And so when we do that math, we end up with 31. And then we can go to our periodic table. That is the atomic number for something. So we've got to look up 31 for the atomic number in our periodic table. We see that it is Ga. So we would write Ga right here as the element. Okay. So let's go ahead and do another one. This one asks the question a little differently. It says that we've got bismuth 210. So right away we know we're starting off with bismuth and its mass is 210 because that isotope that we're specifically talking about here is bismuth 210. So that number goes on the top. It says it goes through alpha decay. So if it's alpha decay, that means alpha particles are going to be given off. So right away on the product side we can put an alpha particle, which is basically your helium nucleus. And it's asking us for what's the other product. Okay. So first of all, bismuth, we have to finish up what the numbering is on here. So we can look for Bi on our periodic table. We can see that it's right here. And we look for the atomic number, and the atomic number is 83. So now we can then do the math. So we've got 210 has to equal 4 plus some number. Okay. Do the math, subtract 4 from both sides, and we get 206 as our unknown. Do the same thing for the bottom. 83 over there has to equal 2 plus some number. Subtract 2 from both sides, and our unknown happens to be 81 down there. Now, remember, it's the bottom number that tells us what this thing happens to be. So we look up 81 for the atomic number, and we see that it's TL. All right, let's move on to the next one. Here we've got something emitting alpha particles again, and it produces Rn. So now we need to find out what this beginning guy is. So we'll do the exact same thing. Something has to equal 4 plus our 222. We do the math, we add them together, and we get 2, 2, 6. And on the bottom, our number is going to equal 2 plus our 86. You add them together, and we get 88. Go ahead and look up our 88 in our periodic table, and we see that it's over here. It's RA. Okay. So hopefully these types of things, practice them and you'll get in the habit of being able to figure out what these guys are. Now, the questions may be asked a little differently as well. They may just tell you in words what's going on. So let's practice some of those. They're telling us in words what's going on, and we have to figure out what the equation is. Okay. So here it says write a balanced equation for this guy. We know that we start off with aluminum 25. So right away I'm going to write aluminum, and I'm going to write the isotope that has a mass of 25. Put that mass number up there on the top. It says it's undergoing positron emission. So emission means that it's giving it off. So if it's giving it off, then that's a product. Positron is like an electron, but it has a +1 charge, right? And of course it's going to give off something else, okay? Because the masses have to add up. So we look at aluminum. Its atomic number is 13. So we're going to put a 13 down there. Now we can set up our math equations. We've got 25 equals 0 plus our unknown. Well, our unknown would then be 25. On the bottom, we've got 13 equals 1 plus our unknown. Okay. Subtract 1 from both sides, and we're going to get a 12. We look at a periodic table. The bottom number is the one that tells us which thing that we've got. Bottom number tells us that the atomic number corresponds with magnesium. So we can write Mg in there. And this is our balanced equation. Remember, with a nuclear equation, you don't have the same atom on one side as the other. So you don't balance it like chemical equations. You don't put coefficients in front. You have to make sure the numbers on the top equal the numbers on the top on the other side of the arrow. The numbers on the bottom equal the numbers on the bottom of the other side of the arrow. So let's try another one of these where we're dealing with just changing words into an equation. So here we've got chromium 56. So chromium 56. And it says it undergoes beta emission. Emission means to give off. So that means we've got to put a beta over here. And our beta is basically an electron, right? And then it's going to have some other thing there as well. So let's look up chromium on our periodic table, get its mass number, 24. That goes down there. And let's do our math. 56 is got to equal 0 plus our unknown. Well, that means the top number is 56. The bottom number is 24, and it has to equal -1 plus our unknown. Now we have to add 1 to both sides to get rid of that 1. So our bottom number is 25. We can look up 25 on our periodic table, and we can see 25 happens to correspond with Mn. Now, I do want to point out something here. Sometimes my best students will try to do this in their head and will mess up on the fact that you have to add 1 to this side to get to the final number. So do make sure you don't mistake that. This is an easy one to get caught on. Okay. Make sure you're setting up the equations and you're answering them correctly. All right, so our final problem says that we've got radon and the isotope is 222, and it is going to polonium, and the isotope is 218. So we can go ahead and fill these guys in. Rn is clear over here. It's got an atomic number of 86. Polonium is right here. It's got an atomic number of 84. So we're going to fill those guys in. And then we're going to set up our equations. We've got, this down here, 222 equals our 218 plus our unknown. And when we do the math, we find out that our unknown will have a 4 on the top there. And then we've got 86 equals 84 plus our unknown. And we subtract that from both sides, and our bottom number ends up being a 2. So what particle has a 4 on the top and a 2 on the bottom? Well, it's our helium nucleus, right? So this is given off alpha particles. So hopefully here you've gotten some practice at answering questions posed to you in different ways. Sometimes they may have a blank here, sometimes they may want you to figure out what the particle is, other times they'll just use words and you have to figure out what the entire equation is. So hopefully this was very helpful to you and you'll be able to do the homework from here.